I hope you're good. Welcome to today's session. I want us to look at a topic in Form 2 Mathematics, linear motion. Let's start by looking at the definitions of the terms that you're going to be handling in this topic. The first term I want us to define is distance. Distance is defined as the length between 2 points. Distance can be expressed sorry for that, in quite several units. We have kilometers, can be expressed in meters, centimeters, millimeters. We also have miles, inches, etc. The other term we look at is speed. Speed is the rate of change of distance with time, or in other words, distance covered per unit time. The formula is highlighted here. Speed is distance over time. It can be expressed in kilometers per hour, meters per second, centimeters per second, miles per hour, or the knot, including several other units. Velocity. Velocity can be simply defined as speed in a specified direction. When we assign direction to speed, it now becomes a vector quantity, and now that vector becomes the velocity. So the formula for getting velocity is given by distance into brackets. This distance must be in a specific direction divided by time. That will give us velocity. The last term is acceleration. Acceleration is the rate of change of velocity with time. The velocity of an object that is moving might be varying. It might vary from an initial value to a final value within a specified duration of time. To get this acceleration, you need to get the change in velocity, which is obtained by getting the final velocity attained minus the initial or the starting velocity. Then that difference is divided by the duration in which the velocity changed from initial to final. That will give you acceleration. Acceleration is basically or mostly expressed in meters per square units. So in most cases, when you're handling or when you're calculating velocities, it's wise to convert the units of speed. When you're calculating acceleration, it's wise to convert the velocity units to meters per second, so that the acceleration is obtained in meters per square seconds. Let's go to speed. Speed can be defined as the rate of change of distance, or the distance covered per unit time. We had looked at that definition, but in most cases you realize in the course of motion of an object, its velocity or speed will not be the same. It will keep on changing. For instance, a car moving from Nairobi to Kisumu, there are places it will be climbing up hills, there are places it will be climbing down or climbing down hills. So the speeds are going to be different within different sections of the journey. But to get a uniform figure for the whole journey from Nairobi to Kisumu, we take the average speed. We take the average speed, which is found by getting the total distance covered. That is the total distance from Nairobi to Kisumu, for example, divided by the total time taken to move from Nairobi to Kisumu. So most cases we deal with average speed, not just speed within instantaneous sections of the journey. Let's look at this example. A truck traveled from Nairobi to Nakuru, a distance of 150 kilometers. The average speed of the first 80 kilometers was 20 kilometers per hour, and the remaining part of the journey, its average speed was 35 kilometers per hour. Calculate the average speed for the whole journey. So we'll have to go back to the average speed formula and see here. Average speed is given by total distance over total time. So total distance is 150 kilometers. That is the distance from Nairobi to Nakuru. We find the time taken during the first and the last parts of the journey. So time is given by distance over speed. So during the first part of the journey, the distance covered was 80 kilometers and the speed was 20 kilometers per hour. So dividing the distance by speed, we get it took 4 hours to cover the first 80 kilometers. Time for the last part of the journey, which will be found by 150 minus 80, get 70 kilometers. We divide by the speed for that final section of the journey, which is 35 kilometers per hour, and that will give us a time of 2 hours. So it took 2 hours to cover the last 70 kilometers. So total time for the whole journey will be the time for the first section of the journey plus the time for the last section of the journey, which is going to give us 6 hours. So the average speed for the whole journey is going to be given the total distance, the distance between the two towns, which is 150 kilometers, divided by the total time, which is 6 hours, and that is going to give us an average speed of 25 kilometers per hour. Here we have an assignment here. A man walks for 40 minutes at 6 kilometers per hour. He travels for 2 hours in a bus at 80 kilometers per hour, and lastly by fan for 1 hour at 60 kilometers per hour. Find his average speed for the whole journey. You can pause the video at this point and try to solve this question. See whether you get the answer that is shown here. The answer, which is 61.09 kilometers per hour. The walking part distance is going to be given by the time he walked multiplied by the speed of walking, or the walking speed. So he walked for 40 minutes. We divide by 60 to convert this into hours. Then we multiply by the speed, the walking speed, which is 6 kilometers per hour. If we solve this, this is going to give us 4 kilometers. 4 kilometers is the distance that he covered while walking. Then after that, we have the section that he traveled using bus section. The distance is going to be given by time that he traveled by bus multiplied by the speed of the bus. He traveled for 2 hours by the bus, and the bus was moving at a speed of 80 kilometers per hour. So the bus covered 160 kilometers. We also find the distance that was covered by the van. We're going to get the time that it traveled by the van multiplied by the speed of the van. So by the van, it traveled for 1 hour, and the van was moving at a speed of 60 kilometers per hour. So the van covered a 60 kilometers distance. So total distance is going to be given by the distance he walked plus the distance he covered by bus plus the distance he covered by the van. This is going to give a total of 224 kilometers. So now, total time, we had the times that he traveled. Total time is going to be given by he walked for 40 minutes, which is 40 over 60 hours, plus he traveled by bus for 2 hours, give us that 600, which means there are 60 minutes in 1 hour, and each minute has 1 second. So we are converting the hour into seconds. So there are that 600 seconds in 1 hour. This will be the same as getting 75 multiplied by 5 over 18. Once you simplify this, divide this by 20. Simplifying 1000 over that 600 will give you 5 over 18. So if you multiply 75 by 5 over 18, so now the average speed going to be given by the total distance to be 224 kilometers divided by the total time to be 3 hours and 2/3. Solving this will be the same as 224 multiplied by we convert this to improper fraction to be 3 times 3, that would be 9, plus 2, that would be 11. Then we take the reciprocal, it's going to be multiplied by 3 over 11. And this is going to give us a speed of 61.090909. This can be written as 61.09 kilometers per hour. That was the average speed for the whole journey for that man. We now move to velocity and acceleration. Velocity and acceleration. As we said, velocity is the rate of change of distance per unit time or speed in specific direction. So what we need to look at is the average velocity. Average velocity is not found by the total distance over total time like average speed. We take the initial velocity, we add to the final velocity and get the average. That means dividing by 2. So in case you come across a question that requires to calculate the average velocity, you need to get the sum of the two velocities, the initial one, the final one, and then you divide the sum by 2. Example 1. The initial velocity of a van is 10 meters per second. The velocity changes to 30 meters per second after 4 seconds. Calculate the acceleration of the van. The working is shown there. Final velocity is usually abbreviated V, 30 meters per second. Initial velocity is abbreviated letter, small letter u, and it is 10 meters per second, and the time is 4 seconds. So the acceleration will be 5 meters per second. This example, the velocity of a car changes from 75 kilometers per hour to 90 kilometers per hour in 10 seconds. Calculate the acceleration of the car. I'd like us to look at this example and try to solve it together. You can as well pause the video and try to see whether you can get the answer that is found in the A is given by the change in velocity over change in time. This change in velocity can be given as a v minus u over t, where v is the final velocity and u is the initial velocity. T is the time taken for the velocity to change from initial to final velocity. Excuse me. So now, I said acceleration in most cases given in meters per square second. So we have to convert the velocities into meters per square seconds. So we start with the initial velocity u is 75 kilometers per hour. To convert this to meters per second, we need to convert the kilometers into meters and multiply by 1,000 because we have 1,000 meters in 1 kilometer. Then we multiply this 1 hour by 60 times 60, which will give us that 600, which means there are 60 minutes in 1 hour and each minute has 1 second. So we are converting the hour into seconds. So there are that 600 seconds in 1 hour. This will be the same as getting 75 multiplied by 5 over 18. Once you simplify this, divide this by 25 over 6 meters. So the final velocity is 90 kilometers per hour. So we multiply this 90 times 5 over 18 to convert it into meters per second. And this will give us 25 meters per second. 25 meters per second. So now you can get now the acceleration, which will be the final velocity, 25 meters per second, minus the initial, which is 25 over 6 meters per second, divided by the time it took for the velocity to change from 20 over 6 to 25 meters per second. And that time was 10 seconds. So solving this is going to give us a 5. The acceleration is going to be 5 over 12 meters per square seconds, or expressing it as a decimal, it's going to be 0.4167 meters per square seconds. The velocities does not increase. Like in this case, the velocity increased from 20 and 5 over 6 meters per second to 25 meters per second within the 10 seconds period. Sometimes the velocity decreases, like in the case of a car applying brakes. Maybe it was at maybe 20 meters per second, and now it decelerates or it reduces its speed until it stops to 0 meters per second. So in this case, we get a negative velocity. Let's look at an example by just inverting. The velocity of a car changes from 90 kilometers per hour to 0 kilometers per hour in 20 seconds due to braking force applied due to brakes applied. Calculate the acceleration of the car. Calculate the acceleration of the car. Acceleration is given by change in velocity, which is the final velocity and the initial velocity divided by time. In this case, the final velocity is 0 kilometers per hour, which will be the same as 0 meters per second. The initial velocity, the car was traveling at 90 kilometers per hour before the brakes were applied. And we saw when you convert this by multiply by 5/18, this gives you 25 meters per second. So now, the time is 20 seconds. So the acceleration is going to be final velocity, which is 0 meters per second, minus 25 divided by 20 seconds. This will give us negative 25 over 20, and this is going to give us a value of negative 25 divided by 20 to give us a value of negative 1.25 meters per square seconds. This becomes the acceleration. But negative acceleration is sometimes referred to as deceleration or retardation. So the retardation stroke deceleration of the car will be 1.25 meters per second. When we use these two terms, we drop the negative sign. 1.25 meters per square seconds. So, of distance against time. This is a distance. If it's a straight line graph, then the slope of this graph represents speed. Velocity time graphs. Velocity time graphs. This is velocity, this is time in seconds. Again, if it's a straight line graph, the slope will represent acceleration, and the distance covered from this t is equals to 0 from this time t will be given by the area under the graph. Distance covered is equals to area under the graph. Vehicles in opposite directions. Excuse me. Vehicles in opposite directions. In this case, relative speed is going to be given by sum of the two speeds. This means in this case the vehicles are approaching each other. Then we have case 2. This case, vehicles in the same direction. This means these two vehicles, one is following another one. One following the other. One vehicle is following the other at any given time. So for this case, relative speed is given by difference of the two speeds. Just get the bigger speed minus the lower speed. So let's look at examples. A van left Nairobi for Nakuru at an average speed of 80 kilometers per hour. After half an hour, a car left Nairobi for Nakuru at a speed of 100 kilometers per hour. 100 kilometers per hour. Find a relative speed of the two vehicles. Then B, how far from Nairobi the car overtook the van. This is our question. You can pause the video, try and solve the question, so that you get the answer. So here we have two vehicles. We have a car that is starting from a town which is being referred to Nairobi, and it is traveling towards Nakuru. This is Nakuru, then this is Nairobi. So the van left from Nairobi to Naivasha at 80 kilometers per hour. The car leaves from Nairobi to Nakuru at 100 kilometers per hour. So the first question we are looking for is the relative speed, sometimes abbreviated like just RS. And because these vehicles are moving in the same direction, they are both heading to Nakuru from Nairobi, we get the difference of their speeds will be the relative speed. So we get 100 kilometers per hour. We subtract 80 kilometers per hour, and the relative speed will be 20 kilometers per hour. That will be the solution to part A. So now part B, we need to get that point where the car overtook the van, and we find how long or how far is that point from Nairobi. So assuming they met a point here, not meeting but this overtaking point. So this is the distance we're looking for. The distance from Nairobi to this point where the car overtook the van. That is the distance we're looking for. So to get that distance, we first need to calculate the time it took for the car to catch up with the van. And to get that, we need to use the relative speed and the distance between the van and the car when the car was starting to move. Remember, the van left 30 minutes earlier. Because we are told the car left Nairobi after half an hour, meaning that for that half an hour the car was not moving, the van was moving, and it had created some distance between Nairobi and its current position. So we first calculate the relative distance. Relative distance, this is simply the distance between the two vehicles. The distance between is going to be equivalent to the distance that was covered by the van. This duration when the car was not moving. So we're going to get relative distance be distance covered by van before the car started. So this is going to be given by the speed of the van, which is 80 kilometers per hour, multiplied by the time, which is half an hour. And this means it had covered 40 kilometers. Within that half an hour it was moving when the car had not yet started moving. So now we now calculate the time it took the car to catch up with the van. Time to catch up and overtake. This is going to be given by the relative distance divided by the relative speed. Is going to be given by the relative distance, which is 40 kilometers, divided by the relative speed, which is 20 kilometers per hour, and that is going to give us 2 hours. Excuse me. So now, this means the car traveled for 2 hours from Nairobi. Before catching up and overtaking the van. So if we calculate the distance that was covered by this car, that will be the distance of the overturning point from Nairobi. So distance from Nairobi B is equal to the distance traveled by the car. And that is going to be given by the speed of the car. We multiply this by the time it took for the car to catch up with the van, which is going to be 200 kilometers. That becomes the distance of the catch overtaking point from Nairobi. Alternatively, you can use the van within the first 30 minutes, the half an hour, the van had covered 40 kilometers from Nairobi. Then it also covered 2 hours within the time the car caught up with the van was also moving. So this distance, it also covered a distance of 80 kilometers per hour, its speed multiplied by the time it took the car to catch up with it, which was 2 hours. And this is going to give us 160 kilometers. If you had this 160 kilometers and this 40 kilometers, it will still give you these 200 kilometers. That is another alternative way. Back left, Nyeri at 7 a.m. from Nairobi. At a speed of 60 kilometers per hour. At 8 a.m., a bus left Nairobi for Nyeri at 120 kilometers per hour. Find how far from Nyeri did the vehicles meet? If Nyeri is 160 kilometers from Nairobi, so here we have again we have two vehicles that are moving in opposite direction. let this be in Nyeri and this be in Nairobi. The truck is leaving from Nyeri to Nairobi at 60 kilometers per hour, while the bus is leaving from Nairobi to Nyeri. This is the bus and it is traveling at 120 kilometers per hour. So these two vehicles are moving in the opposite direction. They are approaching one another. So the relative speed for the two will be 120 plus 60, it will be 180 kilometers per hour. That will be the relative speed. We are looking at the point where they met. The truck started exactly at 7 a.m. and the buses started at 8 a.m. So that means the truck was moving for a whole 1 hour before the bus started to move towards Nairobi. So relative distance be distance between the vehicles at 8 a.m. So let's find distance covered by truck by 8 a.m. By 8 a.m. it had already traveled for 1 hour. That will be the speed of the truck, 60 kilometers per hour, times the duration between 7 a.m. and 8 a.m., which will be 1 hour. And this is going to give us 60 kilometers from Nyeri. So at 8 a.m. the truck will be here. It will already have covered this distance of 60 kilometers. So this distance, the distance from Nyeri to Nairobi is 160 kilometers, and by 8 a.m. the truck has already covered 60 kilometers. So now the distance between the two vehicles will be 160. Relative distance going to be 160, the total distance, minus the distance that is already covered by the truck, and this is going to give us 100 kilometers. So the relative distance, which is the distance between these two vehicles at 8 a.m., will now be 100 kilometers. Taken to meet, it's going to be given by the relative distance divided by the relative speed, and this is going to be 100 kilometers divided by 180 kilometers per hour, which is the relative speed. This is going to give us a 5/9 hours. This is going to give us 5/9 hours from a calculator. So that means from 8 a.m. the bus will travel from 5 and 9 hours to the meeting point. The truck will also travel for the same 5/9 hours to the meeting point. So now we calculate the distance of the meeting point from Nyeri. So I want to call this my meeting point, MP. So I want this distance. So because we already know the distance from Nyeri to where the track was at 8 a.m., that is 60 kilometers, we can as well calculate the distance covered by the track from 8 a.m. to the meeting point. It traveled for just 5/9 hours. So we calculate distance traveled by track after 8 a.m. to the meeting point. This is going to be given by the speed of the track, which is 60 kilometers per hour, multiplied by the time they both took to travel to the meeting point, and this is going to be 60 times 5/9, and this is going to give us 33.33 kilometers. So the distance of the meeting point from Nyeri town distance of meeting point, I call it MP, from Nyeri will be given by 60 kilometers. The distance the track traveled from Nyeri between 7 and 8 a.m. plus 33.33 kilometers. The distance the track traveled to the meeting point as from 8 a.m. and this is going to give us 93.33 kilometers. There is also an alternative of trying to solve this same question. Distance traveled by bus from Nairobi. This is going to be given by the speed of the bus, which is 120 kilometers per hour, times the time it took to travel to the meeting point. They both took 5/9 hours, and this is going to give us 5/9 multiplied by 120. This is going to give us 66 kilometers, 66.67 kilometers. So distance of meeting point from Nyeri be given by the total distance between Nairobi and Nyeri, 160 kilometers, minus that distance between Nairobi and the meeting point, is 66.67 kilometers. And this is going to give you the same 93.33 kilometers. Let's look at another example, and probably the last one. This is the question. The distance from Mwangi's house to Onyango's house is 40 kilometers. One day, Mwangi left his house at 9 a.m. and cycled towards Onyango's house at an average speed of 20 kilometers per hour. Onyango left his house at 10:30 a.m. on the same day and cycled towards Mwangi's house at an average speed of 30 kilometers per hour. Determine the distance from Mwangi's house where the two met, Roman 2, the time of the day when they met. Then lastly, the two continued with their journey until each reached their destination. Determine who reached its destination earlier and by how much. So let's try and solve this question. And then we have a distance that connects his house to Onyango's house. This is Onyango's house. And this is Mwangi's. So Mwangi left at 9 a.m. and cycled towards Onyango at an average speed of 20 kilometers per hour. Whereas Onyango left his home 10:30 a.m. and cycled towards Mwangi's house at an average speed of 30 kilometers per hour. The distance between them, their homestead, is 40 kilometers. So now we first need to calculate the relative speed. If we have to get the point where the two met, then we have to use the relative speed and the relative distance. So we start with the relative speed. These two people are moving in opposite directions, so the relative speed will be the sum of their two speeds plus 30 kilometers per hour, and this is going to be 50 kilometers per hour. So now we need to get the distance between Mwangi's position and Onyango as Onyango was starting, because Mwangi started a bit earlier. So Mwangi started 1.5 hours earlier than Onyango. So by 1.5 hours earlier, Mwangi will have covered some certain distance from his home. So at 10:30, he'll be around a place here. So we need to calculate this distance. So distance covered by Mwangi by 10:30 a.m. This is going to be given by Mwangi's speed, 20 kilometers per hour, times 1.5 hours, which will be 3/2, and this is going to be 30 kilometers. So by the time Onyango is starting, Mwangi has already covered 30 kilometers. The distance from Mwangi's home to where he will be at 10:30. So now the relative distance between them. Relative distance is going to be the distance between them, at 10:30, the time Onyango was starting. So this is going to be given by the total distance between their home minus the distance that Mwangi had covered, and that will be 10 kilometers. So that means this distance here will be 10 kilometers, and that will be the relative distance between them. So now you can calculate the time they took to meet, because we have the relative speed and the relative distance. It will be given by the relative distance over the relative speed, and that is going to be given by the relative distance. The distance between them is 10 kilometers, and the relative speed was 50 kilometers per hour. So this will be 1/5 hours. It will be the same as 12 minutes. 12 minutes when you multiply by 60. So that's the time it took for them to meet, but you are not interested in the time. You are interested in the meeting point. How far is it from Mwangi's house? So we want to calculate, because we know from 9 to 10:30, Mwangi had covered these 30 kilometers. And now because it took 12 minutes or a fifth of an hour to meet, that means he traveled for another 1.5 hours to the meeting point, while Onyango also traveled the same time to the meeting point. Onyango also traveled for the same period of time to the meeting point, 5 hours. So if we calculate this distance, and then we add up to this distance, then we get the distance of the meeting point from Mwangi's house, because this is the Mwangi's house. So distance covered by Mwangi, distance covered by Mwangi after 10:30 a.m. is going to be given by his speed, which is 20 kilometers per hour, multiplied by the time he traveled, which is 1/5 hours. So Mwangi covered 4 kilometers. Mwangi covered 4 kilometers after 10:30 to the meeting point. So now to get the distance of the meeting point from Mwangi's house, we take the 30 kilometers he covered between 9 and 10:30 plus these other 4 kilometers he covered to the meeting point after 10:30. Time of the day that they met. After 10:30 a.m., Mwangi traveled for 1/5 hours, which is the same as 12 minutes. So the time is going to be given by 10:30 a.m. We had 12 minutes. And this will be 10:42 a.m. That is going to be the meeting point. This is Mwangi's home. At 10:42, the meeting point. This was Mwangi, and this is Onyango. This was 34 kilometers, and this was 6 kilometers, because the total distance between their homes is 40 kilometers. At the time they were meeting, Mwangi had covered 34 from his home, and Onyango had covered only 6 kilometers from his side. So now they were to proceed. So we want to calculate from 10:42. These people, because they proceeded after meeting, Mwangi going to Onyango's house and Onyango going to Mwangi's house. We want to see who arrived first and who was last to arrive. Onyango took to cover 34 kilometers towards Mwangi's house. Is going to be given by 34 divided by his speed, which is 30 kilometers per hour. That is the same as 1 hour and 2 or 15. 1 and 2 or 15 hours. This is the same as 1 hour, 8 minutes. That's the time it took. So he arrived. Time Onyango arrived. At Mwangi's. It will be 10:42 a.m. plus 1 hour and 8 minutes. It will be 11:50 a.m. Time Mwangi took to Onyango's is going to be given by the distance that he had left divided by his speed, which is 20 kilometers per hour, and that is going to be 0.6 0.3 hours, which is the same as 18 minutes. So time Mwangi arrived at Onyango's is going to be 10:42 plus 18 minutes. Mwangi's arrival time will be 10:42 plus 18 minutes, and this will be 0 equal 1 hour. It will be 11 a.m. So from there it is clear Mwangi arrived first. Mwangi arrived first and by 50 minutes. By 50 minutes. So that is how we're supposed to tackle that question. For more questions of this type, you can subscribe to my YouTube channel, follow, share, and like. You can also post questions in the comment section. We can interact and engage there. Thank you for your time.